Have you ever stood under a clear night sky, looked up at the countless stars and wondered, where does it all end? What lies beyond the farthest galaxy? Is there an actual edge to our universe? And if so, what's on the other side? Tonight, you're going to explore one of the biggest questions humans have ever asked. My name is Logan Hart, and I'm going to guide you through this cosmic mystery. By the end of this video, you'll understand why asking about the edge of the universe isn't quite the right question. But you'll also discover something even more amazing than any boundary you could imagine. Let's begin. We start with something that might surprise you. When astronomers talk about the universe, they often distinguish between two concepts, the observable universe and the entire universe. The observable universe is everything we can potentially see, all the stars, galaxies, and matter that has had enough time for its light to reach Earth since the Big Bang about 13.8 billion years ago. This observable universe is unimaginably vast, a sphere roughly 93 billion light-years across. Yes, you heard that right. Even though the universe is only 13.8 billion years old, the observable universe is much larger because space itself has been expanding all this time. It's like drawing dots on a balloon and then inflating it. The dots themselves don't move, but the space between them stretches. Within this observable universe, there are around 2 trillion galaxies, each containing billions or trillions of stars. Our own Milky Way galaxy, which looks like a bright smudge across the night sky, contains between 100 to 400 billion stars. And yet, as enormous as these numbers are, they represent just a tiny fraction of what's out there. But here's where things get really interesting. The observable universe isn't the whole universe. It's just the part we can see from our vantage point on Earth. The light from more distant regions simply hasn't had time to reach us yet, since nothing can travel faster than light. So, in a very real sense, the edge of our observable universe is just a horizon, a limit to our vision, not a physical boundary. Think about standing on a beach, looking out at the ocean. You can only see a certain distance before the Earth's curvature creates a horizon. Ships beyond that horizon aren't gone, they're just beyond your ability to see. The cosmic horizon works similarly, except it's created by the finite age of the universe and the speed of light. This horizon is visible to astronomers through something called the cosmic microwave background radiation, or CMB. Discovered accidentally in 1965 by Arno Penzias and Robert Wilson, the CMB is essentially the afterglow of the Big Bang, the oldest light in the universe. When you see static on an old TV, about 1% of that static is actually from the CMB. You're literally seeing the edge of the observable universe on your television screen. The James Webb Space Telescope, launched on December 25, 2021, is designed to see further into this cosmic horizon than ever before. Unlike its predecessor, the Hubble Space Telescope, James Webb primarily observes in infrared light, which allows it to see through cosmic dust and detect extremely distant, ancient galaxies whose light has been stretched to infrared wavelengths by the universe's expansion, but even James Webb can't see beyond the cosmic horizon. No telescope ever could, because the light from those regions simply hasn't reached us yet. So if that's the edge of what we can see, what lies beyond it? The simplest answer is more universe, pretty much identical to what we can see. Most cosmologists believe the universe extends far beyond our observable bubble, filled with more galaxies, stars, planets, and possibly even life. But because we can never observe these regions, at least not from our position in space and time, we can't confirm this directly. We have to rely on our best theoretical models and the laws of physics as we understand them. But now you might be wondering, If the universe keeps going beyond what we can see, does it go on forever, or does it eventually end? This is where things get even more mind-bending and where scientists still actively debate different possibilities. One possibility is that the universe is truly infinite. It extends forever in all directions, with no boundary or edge. In an infinite universe, anything that's physically possible would not only happen somewhere, but would happen an infinite number of times. This means there would be infinite copies of Earth, infinite copies of you reading this script, some identical and others with slight or major differences. This isn't science fiction, it's a legitimate consequence of an infinite universe combined with quantum physics and the laws of probability. The WMAP and Planck satellites, which studied the cosmic microwave background in unprecedented detail, provided evidence that supports the idea of an infinite universe. Their measurements suggest the universe is flat in terms of its overall geometry, which is consistent with an infinite extent. However, these measurements only tell us about the observable universe, so we can't say for certain that the entire universe is infinite. Another possibility is that the universe is finite but unbounded, like the surface of a sphere. If you stand on a perfect sphere like Earth and travel in a straight line, you'll eventually return to your starting point without ever encountering an edge. The universe could work similarly but in 3 dimensions, or more, instead of 2. In 2015, researchers analyzed data from the Planck satellite looking for patterns in the CMB that might indicate a wrapped universe. They didn't find conclusive evidence, but they couldn't rule it out either. The universe might be so large that the curvature is too subtle for us to detect with current technology. But what if the universe does have some kind of boundary? What would that look like? This is where we need to venture into more speculative territory, ideas that are mathematically sound but difficult or impossible to test directly. One possibility comes from a theory called eternal inflation, proposed by physicists like Alan Guth and Andrei Linde. According to this theory, our entire universe might be just one bubble in a vast, ever-expanding cosmic foam of universes. Imagine a pot of boiling water where each bubble represents a separate universe with its own physical laws, dimensions, and possibly even concepts of time and space. In this scenario, beyond the edge of our universe would be a boundary region separating our bubble from the larger multiverse. But this boundary wouldn't be something you could actually reach or cross because it exists outside of our space-time. It would be like asking what's north of the North Pole. The question itself doesn't quite make sense within our framework of space. The BICEP 2 experiment at the South Pole briefly made headlines in 2014 when researchers thought they had found evidence supporting cosmic inflation, and by extension, possibly the multiverse. Though this particular finding was later attributed to cosmic dust, scientists continue searching for the gravitational wave patterns that inflation would have left in the early universe. Another fascinating idea comes from string theory and its extension, M theory. These theories suggest our universe might exist on a brane, short for membrane, floating in a higher dimensional space. In this picture, what lies beyond the universe is a higher dimensional bulk space, possibly containing other branes, other universes with potentially different physical laws and dimensions. The Large Hadron Collider, LHC at CERN, has been searching for evidence of extra dimensions since its operation began. While it hasn't found direct evidence yet, the discovery of the Higgs boson in 2012 provided important confirmation of the standard model of particle physics, which forms the foundation for these more exotic theories. At this point, you might be feeling a bit overwhelmed. The ideas we're discussing push the limits of human imagination and our current scientific understanding, and that's perfectly normal. Even Einstein initially resisted some of the stranger implications of quantum mechanics. and today's leading physicists continue to debate these cosmic questions. But here's something important to remember. You don't need to fully visualize or comprehend these concepts to appreciate their significance. The universe doesn't care about our human limitations. As the astronomer Carl Sagan once said, the universe is not required to be in perfect harmony with human ambition. By the way, if you could peek beyond the edge of the observable universe for just 1 minute, what do you hope you would see? Drop your wildest guess or theory in the comments. I can't wait to read what you imagine is out there. What matters is that you're asking these questions at all. Throughout human history, from ancient stargazers to modern astrophysicists, people have looked up at the night sky and wondered about our place in the cosmos. You're participating in that grand tradition of curiosity, a tradition that connects you to both our ancestors and to the stars themselves. Remember that the atoms in your body, the carbon, nitrogen, oxygen, and other elements, were forged in the hearts of stars that exploded billions of years ago. As astronomer Carl Sagan famously said, "We are made of star stuff." You are not separate from the universe you're trying to understand. You are a part of it, a way for the universe to know itself. This cosmic perspective can change how you see your everyday life. The arguments that seemed important this morning, the deadline you're worried about, the small frustrations of daily existence, they all take on a different character when you realize you're a conscious collection of atoms living on a tiny planet, orbiting an average star, in one of trillions of galaxies in the observable universe, which itself might be an infinitesimal part of a larger multiverse. But rather than making you feel insignificant, this perspective can be empowering. You are connected to something vast and beautiful. You are participating in the universe's greatest known achievement, the evolution of conscious beings who can contemplate their own existence and the nature of reality itself. As we continue our journey to understand what might lie beyond the universe, keep this connection in mind. The quest isn't just about distant galaxies and abstract physics. It's about understanding our origins, our context, and our possibilities. It's about you and your relationship to everything that exists. Now let's dive deeper into some of the most fascinating theories about what might lie beyond our cosmic horizon. Part 2. To truly understand what might lie beyond the edge of the universe, you need to understand something fundamental about space itself. It's expanding. And this expansion is one of the most surprising and important discoveries in the history of science. In the 1920s, astronomer Edwin Hubble made a startling observation. By analyzing the light from distant galaxies, he discovered they were all moving away from us. And the farther away they were, the faster they seemed to be receding. This wasn't because we're at some special center of the universe. From any galaxy's perspective, all other galaxies would appear to be moving away. The explanation wasn't that galaxies were flying through space like rockets. Instead, space itself is stretching, carrying galaxies along with it like dots on an inflating balloon. This cosmic expansion began with the Big Bang and continues today. But here's where things get even stranger. In 1998, 2 independent teams of astronomers made a discovery so unexpected that it eventually earned them the Nobel Prize. They found that the universe's expansion isn't slowing down as everyone had assumed gravity would cause. Instead, it's accelerating. The expansion is speeding up over time. Scientists attribute this acceleration to a mysterious force called dark energy, which seems to permeate all of space and push everything apart. Based on observations from missions like the Hubble Space Telescope and the Dark Energy Survey, dark energy makes up about 68% of the universe's total energy content. Yet we still don't know what it actually is. It's one of the biggest mysteries in modern physics. This accelerating expansion has profound implications for what lies beyond the universe. It means that the observable universe, the part we can potentially see, is actually getting smaller relative to the entire universe. Galaxies that are currently just within our cosmic horizon will eventually slip beyond it, their light unable to reach us as space expands too quickly. The Vera C. Rubin Observatory, scheduled to begin operations in 2023, will conduct the Legacy Survey of Space and Time, LSST, creating the most detailed map of the universe ever made and helping scientists better understand dark energy and cosmic expansion. Given this expansion, one possibility for what lies beyond the observable universe is simply more universe that we can't see yet, regions that will forever remain beyond our cosmic horizon because light from those regions will never reach us, no matter how long we wait. This leads to the concept of the future visibility limit. Due to accelerating expansion, there are galaxies whose light will never reach Earth, no matter how long we wait. The boundary containing all events that will ever be observable from Earth is called the cosmic event horizon, and it's currently about 16 billion light-years away. But what if we consider not just the spatial dimensions of the universe, but time as well? After all, Einstein showed us that space and time are actually aspects of a single entity, space-time. From this perspective, the edge of the universe could refer to its beginning or its end. The beginning, as far as we can tell, was the Big Bang approximately 13.8 billion years ago. The end remains uncertain and depends on how dark energy behaves in the future. If dark energy maintains its current properties, the universe will continue expanding forever, leading to what cosmologists call the Big Freeze, or heat death. Over unimaginably long timescales, we're talking about timescales compared to which the current age of the universe is less than a blink of an eye, all stars will burn out, all black holes will evaporate via Hawking radiation, and the universe will become an ever colder, ever emptier expanse of scattered elementary particles. In this scenario, what lies beyond the temporal edge of the universe is simply nothing, or at least nothing recognizable as matter or energy as we understand them today. However, there are other possibilities. If dark energy becomes stronger over time, it could eventually become so powerful that it rips apart galaxies, stars, planets, and even atoms in what physicists call the Big Rip. Alternatively, if dark energy weakens or reverses, gravity could eventually halt and reverse the expansion, leading to a big crunch where all matter collapses back into a singularity similar to the Big Bang. The Nancy Grace Roman Space Telescope, planned for launch in the mid-2020s, will study dark energy with unprecedented precision, helping scientists narrow down these possibilities for the universe's ultimate fate. Some theorists have even proposed that a big crunch could lead to another Big Bang, creating a new universe in a potentially endless cycle. This concept, known as the cyclic or oscillating universe, suggests that what lies beyond our universe's end is another universe's beginning, perhaps even with different physical laws and constants. Roger Penrose, who won the Nobel Prize in Physics in 2020, has proposed a variation called conformal cyclic cosmology. He suggests that the infinitely large, empty universe at the end of one cycle becomes mathematically equivalent to the infinitely small, dense universe at the beginning of the next cycle. Penrose even claims to have found evidence of previous cosmic cycles in the CMB, though most cosmologists remain skeptical. But these theories still assume a single universe, albeit one that might repeat in cycles. What about the possibility of multiple universes existing simultaneously? This is the domain of multiverse theories, which come in several varieties. The simplest type of multiverse emerges from the infinite universe scenario we discussed earlier. If the universe extends infinitely in space, then there must be regions so distant that their observable portions don't overlap with ours. Each of these regions would effectively be its own universe, from the perspective of observers within it, with no possibility of communication between them. A more complex multiverse concept emerges from quantum mechanics, one of the most successful yet strangest theories in physics. According to the many worlds interpretation proposed by Hugh Everett III in 1957, every quantum event creates a branching of the universe into multiple realities. When a quantum particle is in a superposition of states, like Schrödinger's famous cat being both alive and dead, the universe splits, with each outcome occurring in a different branch of reality. If true, this would mean there are countless versions of you experiencing every possible variation of your life, all equally real, but unable to communicate with each other. In this interpretation, beyond our universe lies an unimaginably vast number of parallel universes representing every possible outcome of every quantum event since the Big Bang. While this might sound like science fiction, it's a mathematically consistent interpretation of quantum mechanics that many serious physicists support. The theory is difficult to test directly, but experiments at quantum computing facilities like Google's Quantum AI Lab and IBM's Q network are pushing the boundaries of quantum superposition, potentially shedding light on these fundamental questions. If you are still watching, please consider giving a like and subscribing. I am starting now on YouTube, and your help means a lot to me. Another multiverse theory emerges from string theory, which attempts to reconcile quantum mechanics with Einstein's theory of general relativity. String theory suggests that particles are actually tiny vibrating strings, and their properties depend on how these strings vibrate in 10 or 11 dimensions, far more than the 3 spatial dimensions we experience. For string theory to work mathematically, these extra dimensions must be compactified, rolled up so tight that we can't perceive them. But there are multiple ways this compactification could occur, around 10 to the power of 500 different possibilities, each creating a universe with different physical laws. This string theory landscape suggests an enormous multiverse where every possible set of physical constants is realized somewhere. The idea that other universes might have different physical constants is particularly fascinating. In our universe, constants like the strength of gravity, the mass of electrons, and the speed of light seem perfectly tuned to allow for complex structures, including life. Change any of these values slightly and stars, planets, and certainly life as we know it couldn't exist. This fine-tuning has led some to propose the anthropic principle, the idea that we observe these particular physical constants precisely because they're the ones compatible with our existence. In a multiverse with varying physical laws, intelligent observers would naturally find themselves in universes whose constants allow for their evolution. The European Space Agency's Euclid mission, launched in 2023, is designed to map the structure of the universe with unprecedented precision, potentially providing indirect evidence for or against multiverse theories based on how matter is distributed on the largest scales. Each of these multiverse theories suggests something different about what lies beyond our universe, whether it's more universe we can't see, parallel branches of reality, bubble universes with different physical laws, or higher dimensional brains containing entire universes. The honest truth is that we don't know which, if any, of these theories is correct. Some may never be directly testable, existing at the boundary between physics and metaphysics. But they all emerge from our best understanding of the laws of physics, extended to their logical conclusions. What's remarkable is that humans, collections of atoms that have been conscious for an eye blink of cosmic time, can conceive of these possibilities at all. Your brain evolved to help your ancestors find food and avoid predators on the African savanna, can nonetheless contemplate multiple dimensions, quantum superpositions, and the beginning and end of time itself. This cosmic perspective isn't just scientifically fascinating, it can be personally transformative. When you understand that the universe is vaster, stranger, and more mysterious than everyday experience suggests, it opens your mind to new possibilities in your own life. The limitations you perceive, the boundaries you accept, these might be as illusory as the apparent edge of the universe. As you go about your day, after watching this video, I encourage you to carry this cosmic perspective with you. When you look up at the night sky, remember that you're not just seeing stars and galaxies, you're peering toward a horizon beyond which lies what? More universe, parallel realities, higher dimensions. The question itself connects you to a tradition of human curiosity that stretches back to our earliest ancestors and forward to the edge of what we can know. Now let's explore some of the most fascinating efforts to actually detect evidence of what might lie beyond our observable universe. If these ideas about what lies beyond the universe seem impossibly abstract, you might be wondering, is there any way we could actually detect evidence of other universes or higher dimensions? Surprisingly, the answer is possibly yes. Scientists around the world are conducting experiments and making observations that might give us glimpses beyond our cosmic horizons. One intriguing possibility involves something called cosmic bruises. If our universe collided with another bubble universe in the multiverse, it could leave subtle patterns in the cosmic microwave background radiation. Scientists have been scouring data from the Planck satellite looking for these unusual circular patterns that might indicate where our universe bumped into another. In 2018, researchers from the UK claimed to find evidence of these cosmic bruises, suggesting our universe has collided with at least 4 others. However, most cosmologists remain skeptical, noting that similar patterns could arise from more mundane causes. The upcoming Simons Observatory in Chile's Atacama Desert will make even more precise measurements of the CMB, potentially settling the question. Another approach involves searching for evidence of extra dimensions. While we can't directly perceive dimensions beyond the 3 spatial dimensions of our everyday experience, their existence could affect phenomena we can measure. For instance, if gravity can propagate through extra dimensions, it would behave differently at very small scales than our current models predict. Experiments at facilities like CERN's Large Hadron Collider are looking for these deviations, which could provide evidence for string theory and its predictions about higher dimensions. The LHC's discovery of the Higgs boson in 2012 was a triumph for the standard model of particle physics, but scientists are hoping future runs at higher energies might reveal exotic particles that could provide evidence for supersymmetry, extra dimensions, or even microscopic black holes, all of which connect to theories about what might exist beyond our universe. Gravitational waves, ripples in spacetime first directly detected by LIGO in 2015, offer another window into the possible multiverse. These waves can carry information from the earliest moments of the Big Bang, potentially revealing whether our universe underwent a period of rapid inflation as many theories suggest. The BICEP array and other experiments at the South Pole are specifically designed to look for a particular pattern of gravitational waves in the CMB that would provide strong evidence for cosmic inflation, and by extension, support for the idea of a multiverse of bubble universes. Even more ambitious is the proposed European Space Agency mission called LISA, Laser Interferometer Space Antenna, planned for the 2030s. This space-based gravitational wave detector would be sensitive enough to detect gravitational waves from the Big Bang itself, potentially providing direct evidence of cosmic inflation and perhaps even hints of what came before. Our universe began. Another fascinating possibility involves black holes, these cosmic monsters where gravity is so strong that nothing, not even light, can escape, might actually be portals to other universes. This idea emerges from theoretical physics, particularly the work of physicists like Stephen Hawking and Kip Thorne. Inside a black hole, our current understanding of physics breaks down at what's called the singularity, a point of infinite density. But some theories suggest this singularity might connect to another region of space-time, perhaps even another universe entirely. These connections are called Einstein-Rosen bridges, or more commonly, wormholes. While we can't directly observe inside black holes, the Event Horizon Telescope has given us our first image of a black hole's shadow, and future observations might reveal more about their nature. The Nobel Prize-winning detection of gravitational waves from colliding black holes is also providing new insights into these mysterious objects. Some physicists even speculate that the creation of new universes might be a natural process that occurs inside black holes. According to this theory, each black hole in our universe might give birth to a new universe, with slightly different physical properties. Our own universe might have been born from a black hole in another parent universe. This concept of cosmological natural selection, proposed by physicist Lee Smolin, suggests a kind of cosmic evolution, where universes that produce more black holes have more offspring universes. Over time, this would favor universes with physical laws that maximize black hole production, which, interestingly, also seem to favor the evolution of life and intelligence. Quantum entanglement offers yet another potential window beyond our universe. This bizarre quantum phenomenon, which Einstein called spooky action at a distance, connects particles so that measuring one instantly affects the other, no matter how far apart they are. Recent theoretical work suggests quantum entanglement might cross between parallel universes in the many worlds interpretation, or even connect our brain universe with others in higher dimensional space. While direct evidence remains elusive, experiments with quantum computers are pushing the boundaries of our understanding of entanglement. The quantum computing revolution, with major advances from companies like Google, IBM, and research institutions worldwide, isn't just about building powerful new computers. These systems allow scientists to explore the fundamental nature of quantum reality, potentially shedding light on these cosmic questions. All of these approaches, from CMB patterns to gravitational waves to black holes to quantum experiments, share something important. They're based on testable predictions from theories about what lies beyond our universe. This is what separates scientific speculation from pure fantasy. Even the most mind-bending multiverse theories make specific predictions that we can potentially test with observations and experiments. The pace of discovery in cosmology and fundamental physics has been accelerating dramatically. The James Webb Space Telescope is revealing galaxies from the cosmic dawn, just a few 100 million years after the Big Bang. LIGO and other gravitational wave detectors are opening an entirely new window on the universe. Quantum computers are performing calculations that would have been impossible just a decade ago. Each of these advances brings us closer to understanding what might lie beyond the edge of our observable universe. But it's important to maintain scientific humility. The history of science is filled with theories that seemed convincing until new evidence proved them wrong or incomplete. Newton's laws of motion and gravity worked perfectly for centuries until Einstein showed they were approximations that break down at very high speeds or in strong gravitational fields. Einstein's theories themselves don't fully align with quantum mechanics, suggesting we still have more to learn about the fundamental nature of reality. This ongoing quest for knowledge reminds us that science isn't a collection of absolute truths, but a process, a way of asking questions about the universe and testing our answers against evidence. It's the best method humans have developed for understanding reality, but it's always provisional, always open to revision in light of new discoveries. This humility is especially important when contemplating what lies beyond the universe. We're pushing the limits not just of our technology, but of human comprehension itself. The true nature of reality might be stranger than anything we've imagined so far. But rather than being discouraging, this uncertainty is what makes science so exciting. You're living in an era of cosmic discovery unlike any in human history. The questions we're asking today about the multiverse, about higher dimensions, about the beginning and end of time, would have seemed like pure fantasy to scientists just a century ago. And you're not just a passive observer of this scientific revolution. Through your curiosity, through your support for scientific research, through your willingness to contemplate these big questions, you're participating in humanity's greatest intellectual adventure. Remember that the universe doesn't just exist out there in distant space. You are the universe, a collection of atoms that has become conscious and is trying to understand itself. The boundary between you and the cosmos isn't as clear-cut as it seems in everyday life. The hydrogen atoms in your body were created in the Big Bang itself. The carbon, nitrogen, oxygen, and other elements that form your tissues were forged in the hearts of stars that exploded billions of years ago. You are, quite literally, made of star stuff. And your consciousness, your ability to contemplate these cosmic questions, is perhaps the universe's most remarkable creation. Through you and all conscious beings, the universe has evolved the capacity to reflect on its own existence, to ask questions about its origin and fate, to wonder what lies beyond its own horizons. Speaking of cosmic questions, if you're fascinated by what might exist beyond our universe, you'll be amazed by what might have existed right here on Earth before humans. Could an advanced civilization have thrived millions of years ago? I explore this mind-bending NASA theory in my video called "What if we are not the first civilization on Earth?" The link is in the description. Now back to our journey beyond the universe. This deep connection between your existence and the cosmos gives these abstract questions about what lies beyond the universe a personal relevance. You're not just asking about distant realms of physics. You're exploring the context of your own existence, the larger reality of which you are a part. As we continue our exploration of what might lie beyond the edge of the universe, keep this connection in mind. The journey isn't just outward to distant cosmic realms, it's also inward, to a deeper understanding of reality and your place within it. Let's now turn to some of the most profound philosophical implications of these cosmic questions and how they might change your perspective on life here on Earth. Part 4. The question of what lies beyond the universe isn't just scientific, it's deeply philosophical. Throughout human history, people have contemplated the boundaries of existence and what might lie beyond them. These cosmic questions touch on fundamental issues of meaning, purpose, and our place in reality. In many cultures and religious traditions, what lies beyond the physical universe is the realm of the divine, whether that's the Christian concept of heaven, the Hindu Brahman, or the Taoist Tao. These traditions suggest that ultimate reality transcends the physical world we can observe and measure. Modern physics doesn't necessarily contradict these spiritual perspectives. The multiverse, higher dimensions, and other exotic cosmological concepts expand our notion of what reality encompasses. They suggest that what we can directly observe might be just a tiny fraction of what exists. The philosopher Immanuel Kant distinguished between the phenomenal world that we can experience and the noumenal world as it exists in itself beyond our perception. Modern cosmology gives this distinction new meaning. Our observable universe might be just the phenomenal tip of a much larger noumenal reality that we can only access through mathematics and theoretical physics. This perspective can be both humbling and liberating. Humbling because it suggests that human perception and understanding are far more limited than we typically assume. Liberating because it opens the possibility that reality is far richer and more diverse than our everyday experience suggests. Consider how profoundly our understanding of the cosmos has expanded throughout human history. Ancient cultures typically imagined the universe as a small, contained system, perhaps a flat Earth covered by a dome of stars. The scientific revolution expanded this picture dramatically, revealing that Earth is just one planet orbiting an average star in a vast galaxy containing billions of stars. The 20th century brought another radical expansion of our cosmic perspective. Edwin Hubble's discovery that many nebulae were actually distant galaxies revealed that the universe contains billions, now known to be trillions, of galaxies, each with billions or trillions of stars. The discovery of the Big Bang showed that the universe has a history extending back nearly 14 billion years. Now, theories about the multiverse, higher dimensions, and other exotic possibilities are pushing the boundaries of reality even further. Each expansion of our cosmic understanding has required us to reconsider our place in the universe and what it means to be human. This cosmic perspective can transform how you think about your everyday life. The problems that seem overwhelming, the deadline at work, the argument with a friend, the political conflict in the news, take on a different character when viewed against the backdrop of multiverses and cosmic evolution. This doesn't mean your daily concerns don't matter, but it does provide a larger context that can help you navigate life's challenges with greater perspective and equanimity. As the philosopher Seneca wrote nearly 2,000 years ago, the cosmos is everything that is and ever will be. We are a minuscule part of it. We are here for a blink of an eye. But rather than making you feel insignificant, this cosmic perspective can be profoundly empowering. You are connected to something vast and wondrous. You are participating in the universe's greatest known achievement, the evolution of consciousness capable of contemplating its own existence and the nature of reality itself. The atoms that form your body have existed since nearly the beginning of time, cycling through stars, interstellar clouds, planets, and now you. They'll continue their cosmic journey long after your conscious experience ends. In this sense, you are immortal, not as an individual consciousness, but as a collection of matter and energy that will continue to participate in the cosmic dance forever. This perspective echoes ancient wisdom traditions. As the Upanishads state, "Thou art that, you are not separate from the ultimate reality." Or as Jesus said in the Gospel of Thomas, "The kingdom of heaven is spread upon the earth, but men do not see it." The cosmic perspective of modern physics gives these insights new meaning. When you look up at the night sky, you're not just seeing distant objects. You're seeing your larger self, the cosmic whole of which you are a part. The boundary between you and the universe is more permeable than it appears in everyday experience. This cosmic connection isn't just philosophical, it's practical. Understanding that you are the universe becoming conscious of itself can transform how you relate to others and to the natural world. If all beings share this cosmic heritage, it creates a foundation for compassion and ethical treatment of others that transcends cultural or religious differences. It also transforms how you might think about humanity's future. If consciousness is one of the ways the universe explores its own nature, then the continuation and evolution of consciousness becomes a project of cosmic significance. Ensuring humanity's long-term survival and flourishing isn't just about our species. It's about preserving the universe's capacity for self-awareness. This gives new meaning to efforts to mitigate existential risks like climate change, nuclear war, or unaligned artificial intelligence. It suggests that humanity's most important role might be as conscious stewards of Earth and potentially the larger cosmos, preserving and expanding the reach of consciousness and complexity in a universe that otherwise tends toward entropy and simplicity. The cosmic perspective also transforms how you might think about your individual life and choices. If you are the universe becoming conscious of itself, then your explorations, your creative works, your acts of kindness and connection are the universe's explorations. Your life isn't separate from cosmic evolution, it's an integral part of it. This doesn't mean you need to do anything grand or world-changing. Being fully present in your everyday experiences, appreciating the wonder of existence, and treating others with compassion and respect are profound contributions to cosmic evolution. As the poet Walt Whitman wrote, "I believe a leaf of grass is no less than the journey work of the stars." The question of what lies beyond the universe ultimately leads back to you, here and now. The boundary between out there and in here is more fluid than it appears. The same principles that govern cosmic evolution, emergence, complexity, connection, operate in your daily life and relationships. As you go about your day after watching this video, I encourage you to carry this cosmic perspective with you. When you feel stressed or overwhelmed, zoom out mentally to the scale of galaxies and imagine what might lie beyond our cosmic horizon. When you feel joy or wonder, recognize that you're experiencing the universe becoming aware of its own beauty through your consciousness. This perspective doesn't answer all questions or solve all problems. The mystery of what lies beyond the universe remains largely unsolved, and your daily challenges remain real. But viewing your life through this cosmic lens can provide a sense of meaning, connection, and wonder that transcends the limitations of ordinary experience. The edge of the universe isn't just a distant horizon in space, it's a horizon of understanding, a boundary between what we know and the greater reality that remains to be discovered. And you, through your curiosity and consciousness, are participating in humanity's ongoing journey beyond that horizon. Let's conclude by bringing together what we've learned about what might lie beyond the universe and how this cosmic perspective might transform your understanding of reality and your place within it. Part 5. Throughout this journey, you've explored some of the most mind-bending concepts in modern cosmology, from cosmic inflation to parallel universes, from higher dimensions to the ultimate fate of reality itself. You've seen how the question, what lies beyond the edge of the universe, opens up profound scientific, philosophical, and even spiritual dimensions. Let's bring together what you've learned and consider what it means for understanding your place in the cosmos. First, you've discovered that the edge of the universe isn't quite what it seems. The observable universe, everything we can potentially see, is limited by the finite age of the universe and the speed of light. This cosmic horizon isn't a physical boundary but a limit to our vision, like the horizon at sea. Beyond this horizon likely lies more universe, more galaxies, stars, and planets, similar to what we can observe. The entire universe might be infinitely large, or it might be finite but unbounded, like the surface of a sphere but in higher dimensions. The accelerating expansion of the universe, driven by mysterious dark energy, means that some regions beyond our current cosmic horizon will never be observable from Earth, no matter how long we wait. There's a fundamental limit to what we can see, imposed by the physics of an expanding universe. But modern cosmology suggests even more radical possibilities. Our universe might be just one bubble in a vast multiverse, with each bubble having different physical laws and constants. These other universes might be forever beyond our direct observation, existing in higher dimensions or separated from us by expanding space. Quantum mechanics suggests another kind of multiverse, the many worlds interpretation where reality branches with every quantum event, creating countless parallel versions of you experiencing every possible variation of your life. These parallel realities would be as real as our own, but fundamentally inaccessible. String theory points to yet another multiverse concept, a vast landscape of possible universes with different physical constants, only some of which would allow for the evolution of stars, planets, and life. Our universe's apparent fine-tuning for life might be explained by the simple fact that conscious observers can only exist in universes compatible with their evolution. These theories remain at the frontier of physics, where science approaches philosophy. While they emerge from our best mathematical models, testing them directly presents enormous challenges. Yet scientists are developing ingenious ways to look for indirect evidence, from patterns in the cosmic microwave background to gravitational waves from the early universe. The honest truth is that we don't know with certainty what lies beyond our cosmic horizon. We have compelling theories, mathematical models, and tantalizing hints, but the universe beyond our observable bubble remains largely mysterious. This uncertainty isn't a failure of science, but an invitation to further exploration and discovery. What's remarkable is that we can contemplate these possibilities at all. Your brain, evolved on the African savanna to help your ancestors survive, can nonetheless grasp mathematics that describes higher dimensions and multiverse theories. This capacity for abstract thought is itself one of the universe's most astonishing achievements. The atoms that form your body and brain have existed since nearly the beginning of time. The hydrogen in your tissues emerged from the Big Bang itself. The carbon, oxygen, nitrogen, and other elements were forged in the hearts of stars that exploded billions of years ago, scattering these elements across space to eventually become part of Earth and you. As astronomer Carl Sagan eloquently put it, "We are a way for the cosmos to know itself." Through your consciousness, the universe has evolved the capacity to reflect on its own existence, to ask questions about its origin and fate, to wonder what lies beyond its own horizons. This cosmic connection transforms how you might think about your everyday life. Your existence isn't separate from the universe, but an expression of the same processes that create galaxies and stars. Your consciousness isn't alien to the cosmos, but one of its most remarkable developments. When you feel joy, wonder, love, or curiosity, you're experiencing the universe becoming aware of itself through your consciousness. When you create art, music, science, or technology, you're participating in the universe's ongoing evolution toward greater complexity and awareness. The boundary between you and the cosmos is more permeable than it appears in everyday experience. You are not in the universe, you are the universe, a particular expression of cosmic processes that has become self-aware. This perspective doesn't answer all questions or solve all problems. The mystery of what lies beyond the universe remains largely unsolved, and your daily challenges remain real. But viewing your life through this cosmic lens can provide a sense of meaning, connection, and wonder that transcends the limitations of ordinary experience. As you go forward from this video, I encourage you to carry this cosmic perspective with you. When you look up at the night sky, remember that you're not just seeing distant objects. You're seeing your larger self, the cosmic whole of which you are a part. The stars aren't just out there, they're also within you, in the elements that form your body and the light that enables your vision. This perspective connects you to a tradition of cosmic wonder that stretches back to our earliest ancestors. When ancient humans looked up at the night sky, they too wondered about the nature of the cosmos and their place within it. Their mythologies and cosmologies were attempts to make sense of the same mysteries we explore today with telescopes and equations. The specific answers have changed dramatically, from geocentric models to expanding multiverses, but the questions remain fundamentally the same. What is the nature of reality? What lies beyond what we can observe? What is our place in the cosmic whole? You're participating in humanity's greatest intellectual adventure, the quest to understand the universe and our place within it. This quest isn't just scientific, but also philosophical and spiritual, touching on the deepest questions of meaning and purpose. The edge of the universe isn't just a distant horizon in space, it's a horizon of understanding, a boundary between what we know and the greater reality that remains to be discovered. And you, through your curiosity and consciousness, are participating in humanity's ongoing journey beyond that horizon. As you contemplate what might lie beyond the edge of the universe, remember that the greatest mystery might not be what's out there in distant cosmic realms, but the fact that you, a collection of stardust, can contemplate these questions at all. Your consciousness, your capacity for wonder and understanding, is itself one of the universe's most remarkable creations. In the words of physicist Richard Feynman, the imagination of nature is far, far greater than the imagination of man. What actually lies beyond the edge of the universe might be stranger and more wonderful than anything we've considered. The cosmos continually surprises us with its creativity and complexity, but whatever lies beyond our cosmic horizon, you are connected to it through the fundamental unity of existence. The same physical laws, the same cosmic evolution, the same emergence of complexity from simplicity that created distant galaxies also created you. This cosmic perspective doesn't diminish your individual importance, but places it in a larger context. Your joys and sorrows, achievements and struggles are part of the universe's ongoing story. Your consciousness is the cosmos experiencing itself from a particular vantage point in space and time. As you go about your life after watching this video, I encourage you to occasionally zoom out mentally to this cosmic scale. When daily concerns feel overwhelming, remember that you're part of something vast and beautiful that extends far beyond our observable universe to whatever mysteries lie beyond. If you enjoyed this video and want to keep exploring the universe with me, please consider subscribing. Thank you for being here. And when you experience moments of joy, wonder, connection, or insight, recognize them as the universe becoming aware of its own beauty and meaning through your consciousness. These moments aren't separate from cosmic evolution, but integral expressions of it. The question, what lies beyond the edge of the universe, ultimately leads not just outward to distant cosmic realms, but also inward to the nature of consciousness and reality itself. The boundary between out there and in here is more fluid than it appears in everyday experience. If you enjoyed this video, I am sure you are going to love this other one on the left side. Perhaps the most profound insight from modern cosmology isn't about distant multiverse bubbles or higher dimensions, but about the deep connection between your existence and the cosmos. You are not just in the universe, you are the universe in human form, contemplating itself and wondering what lies beyond its own horizons. Keep looking up at the stars, keep asking these big questions, and keep remembering that you are an integral part of the grand cosmic story, whatever lies beyond its edge.